Hello, let me continue where I stopped last time. As I pointed out to you earlier, this particular series is about how to make use of things which are available with you directly there in your hobby shop, at home, in your classroom, or like me, if you have slightly higher resources, there is no necessity for you to go about trying to book time somewhere else, though after this exercise you will be probably obliged to do that. Now, please have a look at the picture I have here. Can you see? At the background, you just have a graph sheet and various items which are available, which need to be packaged, can all be measured directly on the graph sheet. At the first level, I have directly used things which I have this, the one you see there, this, it is some sort of I am not sure what it is, probably it is a probe or a digital signal injector or continuity test or something. It has two vital components. One is a PCB, it could have been purchased or you can bring it in. There is a display device at the other side, and you can see here it has two LEDs and so on. For this, again let me repeat, for the first instance you probably do not need to have full fledged 3D modeling and all that. All you just need is a graph sheet put on your workbench. So, you have here, see here, other things which I can collect around. This is a very, very low cost vernier. We call it a vernier, some gauge and so on. This portion is the vernier and remaining is the gauge. In fact, several options are there. One is external, then internal, then you also have a depth gauge and so on. The topic is not about the vernier thing. The topic is about finding out how well all these items can go inside. What I showed you already, existing PCB, a pack of 4 AA cells. So, once you have this, you can probably even estimate how much space a two what you call AA cell what you call box can occupy. Then you have again one more standard what you call some, that one is a off the shelf regulator, it is a switching regulator. You can buy it everywhere, and then in India of course for us they are available in several places. The cheapest is probably Amazon, and that is where I got it. And this I am sure you are all familiar with it. It is a telephone or computer jack, RJ11, RJ42 and so on, and you have a small other hardware. First time you will notice that it is the hardware that seems to limit all our packaging what I call issues. You understand, no? All this hardware, especially this holder and this and then this and something to hold these LEDs, cannot be easily modeled in the physical modeling in a normal schematic capture software. The best PCB or PW layout software and schematic software can probably make a neat placement of the components. But the moment you need this and the moment you need this, you end up with the third dimension, and that is where the trouble starts. You remember this yesterday? I tried to show you something which is taken from the existing web. But then you will notice that if this particular board, I am not sure what it is, whether it is a Raspberry Pi or Arduino or it is a Beagle board or whatever it is, most of the time they will give you a general purpose case which will be a little bigger than what you need. I am not sure whether, imagine you want to make something which involves driving a load. Moment you have driving a load, there will be a power device. The moment you have a power device, something will get hot. To dissipate power, you have a heat dissipator of some sort. Moment you have a heat dissipator, you end up with this funny looking things. Though the design is cool, the circuit implementation will be things get hot. So, you end up with things which need to be improved upon, some things have to be added on to that. So, all the time we are adding small add on things. One of the things I showed you is the what I call, that thing is taken from a Pentium cooler, and of course we have not kept the cooler. And then if you see the voltages and all, no, here it says 12 volts, but you also get fans which are 5 volts. And the moment this complexity increases, this all our circuit starts building up. At one level, what starts with a simple PWB, we already have a little few components, and probably on the other side we end up with power devices, and at the bottom of it probably we have a heat spreader, and directly on bottom of it you have a forced air circulation. So, you see things are building up. And what I wanted to tell you, the first time when you make it, all you need is a graph sheet, and then you move on happily. I hope, please if you have a look at it here, this was our final concept. And you notice one more thing is this cooler has been made in a very strategic way. And the moment you make it, you probably need also openings and all, but you see the background is still a simple ordinary millimeter graph sheet. The moment I put it, I need not add anything else. See here, me holding the PWB, something which we may or may not have forgotten are the small standoffs, see in the corner. And every time you need not go about trying to make this complicated mechanism for holding it together. If you are to make it in your own, you can just take the graph sheet, spread all these things uniformly, and after you have spread or made a laid them flat, you can estimate what is going to be the height that is required. In this case, it is probably stopped by the some connector on one side, and finally after you put everything together, you see here, now comes the other thing here. Several of these openings are either they are redundant or they are not present. So, instead of running to a laser operation, you probably from your normal layout, you see here these are small, probably 2 trimmers which need access. A general purpose case will have other openings which you do not need, and it will not have openings such the way we want. So, this is where my suggestion, no, just spread everything neatly on a graph sheet, start doing. And because we need some way of attaching this to this, all this, we need all these details all around like this. Okay. In the first round, it will be much easier if you just hold everything together, probably even make things by hand. Not long ago, means around 20 years back, before tabletop or desktop devices came, all these things were made the way I told you about it, and even today it is practical for you to make these things the way it is. Now you see these two openings are meant for power supply, and here is probably something aligned to this, and then you have a USB things. All these details we just look at it from all the other directions, you can easily get it there. You can see this. Oh, it's I mean, I am not sure it's USB or it is a type C or it is a HDMI or whatever it is. You have this connector which shows all these things, and in case you have the device already with you, all you require is your mobile, take a print, cut it to scale, and you can play around by rearranging all the components here. So, in the end we have this, and we have everything going for us. Now, I will try to go on a little. Let me what I call amaze you by what students like you have done. It is done by hand, and the whole thing is in cardboard, and front part of it is a printout, probably done by a home printer, and it is a display again done by a home printer, and then we have made a exercise, because this exercise was specifically in cardboard modeling. Keep it simple, and we are not going to ask you about the how good you are in the detailing, but in the concept, but how well you are able to make it. So, this student was good enough to even make us a switch, and all this are probably directly taken and printed from the available material on the internet, including the display and all that. See here, first time you will notice that it is very convenient for us, and you see another child has made a camera. Good, I am thrilled. And everything has been made with flat cardboards, and probably in our shop. Now, we will get back to the original question saying, sir, why are we getting into all this when very easy for me, even I have a home printer at home, 3D printer, not just ordinary 2D printer, 3D printer. Suddenly you will notice that what looked okay is even not so great in the case of a 3D print. Noticed it, and even there detailing for 3D printing is very critical. If you have any recesses, and if you have anything else, especially sloping, you get a funny stepped image, which is very tough and does not build as well as you want, and very thin sections still require finishing of the unit when it is received. After it is received, you still have to finish the unit a lot, meaning take it and keep on pressing it and all that. All that can be avoided at first time if you try to make a flat thing. So, all of them have been placed here. You see here, I spent a little time with my colleagues who helped me, and luckily we have a professional cutting board. This one is made of some, I am not very sure what the material is, a sponge like material where all of this is printed, and we can arrange things directly on this. You do not need it. All you probably require is a graph sheet on top of which you have a glass plate. So, at the bottom most you have some flat surface like your table, on top of it you have a graph sheet, on top of it you have a glass plate, and you can arrange things directly on that. Why the glass? Because then the graph sheet is not stained, and the base sheet can contain the printable area of your printer that you have at home. So, the moment you have it, now it is easier for us to go ahead and make very interesting things. I wanted to make, as part of the student exercise, can I make a remote which slightly different from what is usually sold to us by various companies. One of the first thing is it does have a peculiar angular this thing, saying that is part of the design, and second thing is you have seen here, it is intentionally made to look upside down. You really do not need a large area for a display and crowded keys at the bottom. So, instead I decided the display need to be small and the keys area can be big and it should nestle comfortably in the hand. So, I have come out with a concept like this and I requested my colleagues to help me out, and luckily they helped me out. You see here, whole thing is printed on an A4 sheet, other variants, more variants. It has been stuck on a thicker what do you call a board, and as I told you, on by principle we wanted to have it locally made and what do you call to be printed. So, they have taken a what do you call slightly thicker cardboard which you can all the school kids and all use, stick the developed item onto that, then cut it and release it using a straight edge. And did I show you that cutting board? That cutting board is made with a special plastic. So, when you turn it over on the other side, this is a type of a self-healing memory device. You can cut, and if you just leave it alone, things join together and you can use it again and again. And this particular device is being carefully used by we have a professional model maker. He has been using it since 20 years, but he knows how to use it as such, there is no problem. Now, you see here that printed sheet, carefully he has tried to fold it. Little closer, process of cutting, trying to attach it together, while the other one had only flat features. This one for the first time also has other features in it. The advantage, I think, as I was telling you earlier, is that it nestles comfortable in the hand, and I have all the place for the keys. And in the display, this display is going to a very simple display. When, for example, on this side when you are trying to use it, it is probably going to have a volume control buttons which will go up and down, and I have a channel buttons which just shows which is the channel your favorites going up and down, comfortable for me to use. And then if you see this portion of it, it nestles well in the hand. I think I have one of the pictures in which, yeah, see how it is being held. This is towards the object. In this case, it could be a TV or it could be a what do you call audio device, or it could be any of the things like a AC, or it could be our lighting, or it could be our audio devices and all that. And you will notice here, this is the palm and it fits neatly in the palm here, and this inclined surface and this here, there are place for me to place additional keys on this side, which I expect the moment I manipulate all these things, the amount of keys that I require may be reduced at all. And this is a perfectly symmetrical device. This width here, width from here to here fits exactly the width from here to here. So, if I flip it, other side is equally another variant of it. The way all these, the things which I have shown you earlier, it is being cut, such of the features that are straight. This particular device has been made such that everything given there is straight. See this, all the things including the outlines, everything are straight, so that you can use a straight edge, and for the initial thing this is very very comfortable. But later on when we improved the model, say this is the straight, you understand these parts of it straight, except there is a gentle curve here, and these have got printed because that particular CAD package we have identifies surfaces only like this. I forgot to hide them. Eventually when you hide them and make your own device, most likely we end up with very very useful thing. You have noticed this? This side is towards the receiver, and this is what is in your hand, and the way you put it, I have two big keys which shows up and down, and probably one of them can select one of the functions, other can be selected. It is facing the other way, contrary to normally we have them facing reverse, and a lot of the space is wasted. And then if you take any of the AC remotes, you will notice that the keys have been made for the operation of the or layout of the printed wiring board, not so much as the operations. Now I have here something which just the other way. One face looks like this, other face of it is even simpler. I just have 4 keys. Just wanted to show you the way we can manage various ways of layouts. These are the actual pieces that have been cut, and the main advantage or the feature of it is very easily this whole thing can be passed on to eventually to a laser printing machine. But the first one, since you have done everything and you have not lost anything, you can probably play around with the cardboard, have devices like this and decide what type of this thing is required here. And in fact, if you make it on a cardboard thick enough, it is probably very easy to even populate this, have a display also at the back. You can have a polycarbonate or acrylic window, and the acrylic window can have a mask which shows various things what you want. So I am trying to take you back to time when all this original industrial design and model making was made by hand. Not long ago, before we had this, I think all our laser printing, all this stuff, no, I mean 3D printing and all is probably not more than 20 years old. And we have been having one semi-professional things around 10 or 15 years old, and you can easily do all this by using the best available software package on your PC, and then taking it in a printer, preferably home printer, or in the case of your campus, no, you probably have somebody who does in where I am making this lecture, it is called the campus Xerox. So we know very well Xerox is not there, so campus photo printing. So you can take it to the photo printer, print everything, and I have just been told that the local photo printer which is available nearby can also print all these materials up to 200 GSM paper, which is nothing but a thin cardboard, and one of them is able to give us 300 GSM also. That is as good as you can make a whole circuit just getting it made on top of a what do you call made at home, printed. And again coming back to this display, I can easily rearrange all the components and we can try out various things. This is the reason why Oh, I hope it has come here. Where is it? Where is it? Where is it? It has missed, but I am sure it is hiding somewhere. You see here now, which I thought I will point out. This one was intentionally made flat pieces so that for us to learn how to make it is next to this one was the next one. I have a trapezoidal cross section here, then I have a rectangular cross section. The same trapezoid has been inverted on the other side, and what is called a lofted surface has been made. This lofted surface has a twisted curve followed. No, the advantage of such a device is, first of all, it is symmetric. This is what I had shown you earlier, and the keyboard layout I can play around with it the way I wanted, and most important is this can't be made by either 3D printing or laser cutting, because if you take a thick sheet it does not take this twist easily, and 3D printing give you steps. So now I know at least one place where printing it out on a what I call thick raw material, typically about up to 0.6 millimeters PVC or something, and then giving it a gentle twist like this, it has a very smooth feeling about it. I hope you have you appreciate this. The same thing has been improved here such that you have this. Can you see here? There is a gentle slope here. Everything gets comfortably. Two options. One is it nests comfortable in the hand. Other thing is I can have any layout I want which I can try. And actually when you are trying to arrange things, it is very easy for us from building up a materials library. All these hardware items, if you have the hardware items, it is fine. If you do not have the hardware items, it is very easy. I think you know what it is. It is a small hinged standoff or a support piece by which one goes onto one chassis, another goes onto another some circuit, or in case we have more of them, it can be stacked. Say base plate, first PCB, one more of these devices, second PCB, so that it can be made to open like a book. And now you will see that it is very convenient for you for the at least the first round, when you can get all this printed out. And the fact that this whole thing has been put on a graph sheet and pictured, in this case of course there is a glass underneath the graph sheet is there. Measuring scale is easy, and after you take a photo print of this, you can always cut them and use them as your templates. I am sure some of you will know about it. This is the coin cell holder. Coin cells are very flat and the diameter is big. Typically, I am not able to read, probably it is a 2025 or 2032, 20 mm diameter and around 3 mm height. Button cells look a little like a button. The height and this thing, LR44 and all that come under that. So this is a coin cell, button cell, and then you have all these tubular cells. All these devices, if you go to the manufacturer side, you get a direct picture of it. So all you need to do is arrange all of them in a piece of area in your the computer, and then make a template and keep it. Now your question is, sir, I have an old thing or I have a new thing. The disadvantage, if you have a new cell like this, if you do the mistake of trying to measure its dimension, you may create a very explosive situation. Seen this, no? It is a metallic object. Should never do, even by error, you should never try to put it inside any of these live devices and then try to take a measurement. I am not saying I am a genius or anybody who is listening to it are not careful. in our enthusiasm we may miss something. However, next comes, why can't we use a old old cell like this? Old cells leak and then is going to be a nuisance. Instead, if you just make a plan view, side view and all that, you can arrange all these items here on the graph sheet, and you can probably end up with, even before you make the final device, you can put all the side this here, the front here, the top here and all that, and your final enclosure is ready, and that can next be sent for any further prototyping operation. Typical prototyping operations also include, other than 3D printing and so on, various other things. I will stop this particular presentation this time at this point. We will go on to a new topic next time. So, thank you.